Hi, it's Mike Shaheen with HHO Connection. Today I want to talk about overdriving your dry cell, and by that I mean sending too many amps to a dry cell for the amount of total plate surface area that you have. I always tell people, think of a dry cell like a copper wire. The thicker the copper wire, the more amps that it can handle before it overheats. It's pretty much the same thing with a dry cell. There's a given amount of amps that you can send to any dry cell before you start to overdrive it, and you're going to cause excess heat, and you're also going to cause things like impurities to leach out of the plates. That's where you get the hexavalent chromium, and makes your water turn yellow and other crud that you see in your water. A lot of times when you see people with dirty water, it's usually because they're overdriving their cells. Now, in addition to that, it's also going to give you more water vapor, which you don't want. You want your gas to be as dry as possible. It's basically just a better gas, better overall running conditions. It's going to make your cell last longer. It's a good rule of thumb just to keep your cells within limits. And the way to figure that out, it's very simple. I'm going to show you there's a formula that we use. And all of this is going to apply to 316L stainless steel only. I can't tell you what the values are for different types of metals like 304 stainless and things like that. This is only going to pertain to 316L in a 12-volt system, which most of us are running now. Okay, so the formula we want to think about. First thing you want to do is take one of your plates from your dry cell. This is an older EBN plate. I'm not going to go with the real dimensions. To keep it simple, let's pretend this plate is a 7 by 7 inch plate. That's what the punch slim lines use back here. So we're going to use this as a reference. But let's say this is your dry cell, whether you're making it or buying it, whatever. This is your plate. Take one plate. Now lay your gasket on top of that. If you notice, this is a 1/2 inch gasket, so it's going to leave a border around there. So now instead of having 7 by 7 inches of exposed surface area, you're only going to have 6 by 6 inside, because again, it's a 1/2 inch border around here. Okay, so you have 6 inches by 6 inches. You multiply that together, it's going to give you 36 square inches. That's the number you want to think about. So take that 36 square inches and divide it by 2. Just cut it in half, 0.5, however you want to think about it. So instead of 36, now you've got 18. That's your magic number. That's how many amps you can send to a one series or one stack of plates. By that I mean one positive plate, one negative plate, and 5 neutral plates in between the two of them. Okay, so 18 amps is the maximum amount of amps you could send to a 7-plate cell that measures 7 by 7 with 6 by 6 inches of exposed surface area. Now if you want to get picky about it and take out for the holes in the plates, you might knock a couple amps off that, maybe take it down to 16 or even 15 to play it safe. Now you say, okay, I need more amps than that. I need that 15 amps is only going to give me 1 liter a minute, but I need 3 liters a minute. So what do? It's simple. You just add more stacks to it. So in this case, since you have 18 amps, if you add a second stack to it, that's going to give you a total of 36. So if you had a 13-plate cell, which would be two separate stacks, be 18 plus 18 or 36 amps that you could put at it, and probably get you close to 2 liters a minute. Add one more to that, a third stack, and you're talking about what would it be, 54 amps? I got to do my math here. 54 amps, it puts you to 3 liters a minute, and so forth. Every time you add another stack, you're just adding another 18 amps to that. Okay? I hope it makes sense. It's a very simple process. No need to overthink it, but just keep that in mind if you're going to build or buy a dry cell. Think about first of all, how many liters a minute you're shooting for, and you say, okay, if I need 2 liters a minute, I'm going to need to try to get at least 36 amps. And how big of a dry cell I'm going to need. Take these numbers that I just showed you and figure out if your dry cell is going to be big enough. I hope it helps. Take care.